I will talk today about secure development with Android. First, one question: how many people are Android developers here? Okay, so the ones that are not, I hope you learn a lot. The ones that you already are, I hope you learn a lot as well. Yeah, this is my profile. My name is Enrique. I'm originally from Spain, but I live in Munich, in Germany. I'm an IT consultor, part of the Google Developer Expert crew. And if you want to follow me on Twitter, I will later post the code and the presentation. And in general, if you have any questions, you can at any time write me there. I try to be very diligent and interact with people there. So it would be a pleasure for me to catch up there with you. What I want to talk today is security in Android. How can we make secure applications secure and efficient and avoid to fall into mistakes that lead us into losing data or connect to services that are not safe, etc. Security is huge. So I know more or less how many Android developers there are. How many people has been working with security topics here before? Okay. So security, it's something huge. You can focus on networking. You can focus on storage of files. You can focus on many, many things. So I try to constrain everything here a little bit. And those are the topics I came up with that I think they will be very, very interesting. By the way, if at any time I speed up, it's a problem because I'm Spanish and we speak very fast. So just make something and I will slow down. I will talk about file storage. That means how can we store files securely? How can we store information in Android in a way that nobody can access this information? I will talk about how to secure network communications. I will talk about reverse engineering. How can we protect our code when it gets delivered? How can we prevent people of accessing our algorithms and our data? I will talk about databases. What are the main mistakes that people do when they're developing databases and talking with databases? I will make a demo. I hope the gods of the demos are today very benevolent. I was praying yesterday. And let's gonna get started. Android. In Android, when we store our files, we have two ways of storing files. One is the external storage, and the other one is the internal storage. The external storage is pretty much the SD card. And to use an analogy, I like to say that the external storage is like when you park your car on the street. All the apps will be able to access the files. The files are not always removed or uninstalled. And the SD card can even be removed or stolen, and we will have this data susceptible of being read by people we don't like it. There are many, I will explain later, a case very funny that happened with WhatsApp, but most of even the big players, they make a lot of mistakes in this sense, because they try to cache some information, they try to save some temporal information on the SD card, and that's something super easy to access from any other application. Then on the other hand, we have the internal storage. Is get files there, this function from here. The analogy would be that it's like parking on your own garage. Other applications normally cannot access your sandbox, so this is secure, cannot be accessed by other processes except root phones and emulator. That's always possible. And files get removed during the uninstallation of the program. When we uninstall something, everything that has been stored in the internal storage gets removed. Some other considerations if you're developing for Android. There are two modes that we should never use. Android, Google provides them, and it's, in my opinion, it's a terrible idea because it's basically giving root access to those files. And there is no way to prevent that an application gets zipped with those flags activated. So if you're developing, you should keep those flags, use them as less as possible. Now, let's gonna move to another topic. Reverse engineering. What means reverse engineering? Well, the definition is getting the source code from a file that has been already compiled. We're typically using our SDK. We're traditionally using the Java SDK from Android. Also, we have Kotlin or Scala. We program our code, we compile it, we generate an APK, which is no more than a zip file that contains all the binaries inside, and we zip that to the user. And as a hacker or as a consultant, what we want is to get back to the original code and see all the vulnerabilities that we can see there. Why Java? Well, Java is partially compiled and then interpreted. The opcodes that we're using, what we are transforming our application, are just a very few, so it's not as complex as other types of languages. It's relatively easy to create a program that brings from the opcodes into the original language. And as we will see, there is no real protection. An application that has been compiled in Java into a binary is pretty much like nothing. So it will be super available to any person that wants to take a look. Why Android? Well, in Android, the APKs are very easy to download. If you're just here if you have a computer, I suggest you going to Google, type APK download, and you will have like 100 different websites. You know how it happens in internet. If you can think about it, it already exists. The obfuscation doesn't always happen by default, so the applications by default will not hide this code. And the translation from an APK, that means the zip file in Android, into a jar is one line of code. This is the typical process we follow when we are developing for Android. We program in Java, or as I said, could be Scala, could be Kotlin, could be any other language. We compile into DEX, that's our binary file. We package everything with resources, with music, graphics, etc., and then we distribute it to the user. Before we actually start, there are a few legal issues to follow here. To make a summary of them, we cannot decompile, recompile, and pass the application, and if this would be our own. A typical... So that's not even the demo got started already. Yeah, now we cannot see the presentation. Now seems to be working. Yeah, now that we have deobfuscated the presentation. So we cannot decompile, recompile, and pass the application, and if this would be our own application. So it's something very typical that, let's say, people develop a video game, I'm a bad person, a bad hacker, I download this video game, decompile, I put my own key for the advertisements, I recompile and put it into one Play Store, people download it, and I get all the revenue from the application. Another point, we cannot try to sell the application, and if it would be our own application, that's obviously not legal. If the license agreement, you know, this thing that we always scroll down, click on yes, even if we haven't read it, and next, forbids the decompilation, we cannot decompile. So bad luck for you guys, now you have to read the license agreement to see if this is possible. And we cannot decompile to remove protection mechanisms. Let's see, now we're a little bit more lucky. It seems to be happening without touching it even. So, as a summary, we can decompile to understand the interoperability, to create a program interface, to interact with other software, but we cannot do it to make profit of it. There can be different purposes. If we think of bad purposes, malware traditionally can download the decompile and recompile to make some code injection. As an example, do you guys know Swift keyboard? For Android, I think there is for iPhone a version as well. Yeah? So this was a very nice keyboard, right? It was learning from yourself, and it was like $5 or $5. So there was a guy that downloaded Swift keyboard as an experiment, put a keylogger inside it, and upload it into a Play Store. Of course, that's terrible, right? Because you're typing your passwords and your credit cards. So this guy was so nice of changing every character into an X. But he was sending this to a public service, a public web service that was reproducing everything that the users were writing. This guy was good. This guy just wanted to make aware of a problem that happens actually in the Android ecosystem. But imagine a guy that doesn't want to do that, a guy that just wants to get credit numbers and passwords. He could just like say, okay, instead of sending this, changing everything on an X and send it to a web service, just sending me an email and we will take care of that. We can also, bad purposes could be being able to steal private information for users when you're typing private information, passwords or personal data, etc. It's a very common use as well in video games. So if you play video games, there is always this guy that has the maximum punctuation, a lot of nines or a lot of zeros, and you think, wow, he must be a very good player. Well, probably he's a very good hacker, but not a good player. Some games are just a web service that you need to send the score you want or share whatever information, they just accept it. You will be surprised on how little companies actually take care of this thing. Or asset manipulations. If you're playing in a video game and you want to say, the game is getting really hard, I would like to play it all the time on an easy level. That's easy. You can uncompile, change the difficulty parameter, recompile, and you will be playing all the time with whatever asset manipulation you have decided. Of course, there is a bright side. We can decompile and recompile because we want to learn how the big players are working. You want to see, hey, how Facebook is creating their applications, which frameworks do they use, how are they encrypting their code. We can use it to research bugs. So when you want to see if those bugs that people find in WhatsApp or Telegram mostly are done because you download the software, decompile it, analyze the code, and see the interactions they have and where can you find a security hole. And to interface, you want to interface with the WhatsApp API, then just download WhatsApp, see the HTTP calls you're doing, investigate them, and create your own API that is going to interact with it. And of course, everybody should do it for their own applications. It's very good if you just download it from the market, you see exactly the productive state you want, you have there, you try to hack yourself and see which vulnerabilities you can find. So a few years ago, I was working doing those things, and I found WhatsApp had a very funny situation. WhatsApp was storing the databases of all their conversations on the SD card. First mistake, why do you store them? But they said, yeah, but it's encrypted. Okay, it was encrypted always with the same key for every user. That's no encryption. When you get it once, you can get the databases from everybody. And the way to go there would have been, okay, I will encrypt it, but based on your hardware ID or on your phone number or whatever. So I developed exploit to, that was actually, you could integrate this in a library, in another application. This exploit was taking the conversations on the background and sending them per email. If I guess you can read programming, so pretty much we went here to this storage, SD card, WhatsApp databases, message store, and send them with a subject to an email address. Easy. Then you receive the conversations on your email address, you just can decrypt them, and it takes like literally 5 minutes to inject the library, put your parameter, and get the conversations from other users. Imagine the risk this have for politicians or people that have a phone and actually are, they're in interesting positions. You can actually read, I will put this thing later, but I wrote about that on this article here. It was not a single bug, but it was a combination of all the previous things that I have been mentioning. At the end, the security is not about finding one thing that is only one single point of failure, but many points of failure that are at the same time connected and allowing you to do this kind of stuff. Well, how can we obtain APKs to play with them? We can pull them from the device. If we install them on the device, they go into a special folder, /data, name of the APK. You just can take them from here, 2 minutes. We can use the Google Play Python API. This is a Java API, a Python API where you just type. No, seems good. That's good, right? Yeah. Okay, but that's not my music. Well, you can use this API in Python. It works pretty easily. You just put your data, username, password, connect to the Google Play through HTTP request and downloads the data you want. Alternative sources, as I mentioned, just Google download APK, hundreds of websites doing that. And we can sniffer the transfers. That pretty much means if, how many people here knows Wireshark? Or Charles? Okay, so pretty much it's software that you put it as a bridge between your application and the internet, and you can sniff absolutely everything that happens. Not only for mobile phones, if you're into security, it's crazy because you just can put Wireshark in any network, in any open network like here, and you will be able to see all the data that everybody's transmitting, and that can be scary. How can we protect ourselves against reverse engineering? There are a few methods you can apply. You can write two versions of the application, one that contains a minimal set of functionality and the other one that contains the entire functionality. Traditionally, one is paid, the other one is free. One can be distributed through another methods, not the Google Play Store. And that will make less likely that your APK will start running on the internet. Obfuscation, of course, that's something critical. We could activate ProWord on our application, and the entire code gets pretty much unreadable. Web services. The mobile phone should be just a very silly layer that takes the information and presents it. There should be as less logic as possible. Everything should be done on the back end. As an analogy, when you develop with PHP, everything is execute on the server and you just send the response to the user. We should follow an approach as close to this one as possible with mobile development. We can fingerprint the code. This is not a protection per se, but if you have the situation where somebody is stealing your code or making a usage of your application, you could prove on a court, hey, that was my code, and you just you just stole it. And native methods. If I don't know how many Android developers here have experience with NDKey. Okay. So NDKey is, you don't have a similar mechanism in other platforms, but in Android it's a system that allows you to get C++ code, compile it, and being able to generate an application with it. ProWord, it's very easy to activate. When we have our release configuration, we just need to take care of including this line here, minify enable true, and then including a ProWord file. We will show later how this looks practically, but it takes all the code, it renames everything, creates new classes, interlaces them, creates fake methods to distract people. This doesn't make it impossible, but in the practice it makes it really hard. Even if enough motivated group of people with a lot of money could spend a lot of resources there and fix it. But it's easy to implement it and protects a high level of security. Now next, Xql Databases. This is a typical code for, let's see, check the login of a user. We send a username to this function and a password, and we execute a query trying to select from our database where the login is the username we had and the password is the password we specified. Is anybody aware of SQL injections here? Okay. So yeah, SQL injections happen as well in other technologies. It's not only in backend and all those things. We can see them in mobile devices. Here, for example, this would be the query we would execute in a normal condition. But an attacker would say, well, I'm just going to insert this part as a username, so the rest will get ignored. I will get a positive answer, and I will just be able to go through the application. Something very easy in the world of Android is to sanitize the SQL injections. So if you see here, we're creating an array of strings and just creating the strings directly from there. So there is no place to SQL injections. Even if we're trying to type this one, this will get dismissed and sanitized before the function actually gets executed. Or another option is to use an ORM. I'm still surprised, and now I work as a consultant, I see a lot of code, I'm still surprised how many companies implement their own SQL solutions. Why? There is a lot of open source solutions that work, that they take care of all those things. You don't want to reinvent the wheel. But I guess sometimes it's difficult to change an entire mentality. I'm going to start doing some demo now. I hope with not a lot of interruptions. I want to show you some sniffing live, checking how we can secure files and credentials, and then making a couple of demos with reverse engineering. So first, let's gonna, if everything is working. Yes. Okay. Can you see it good from everywhere? Yeah. Okay, I made a very small application. It's called SnapHack. You know Snapchat? Okay, this is similar, but it's about hacking. So basically, we have this application here. We have a username, and we have to insert a username and a password. So let's gonna try with username Lviv user, and then something like Lviv password, right? What I'm doing now is I will connect to a web service here, and I will call this web service, sending these parameters as HTTP headers, and I will get this response. That's typically what companies, what service does, right? You log in, you get a token that you can use in all your requests, or you can get like whatever personal information. First mistake, I'm sending everything on plain HTTP. You can imagine what's going to happen here. So you guys know Charles or Wireshark? Some people said, you know Wireshark, right? Okay, so I log in. This pretty much goes to the web service, and now I have a few pictures here, but let's see what happened. I have here this program called Charles. Charles is basically a proxy interceptor. You can communicate the application through Charles, and Charles will take care of analyzing everything you're doing, checking all your headers, being able, you can even make injections of code from here. So if we can here, we see that we call this website from here, lopez-manos.com. The summary of all the requests are here, but we can extend it, and what do we see? I think that's maybe something changed, because I knew that could happen. My IP changed. I already had another one I made before. So this is the request I did before. As a password, I send my password, and as a username, I send my username. So 2 lessons from here. You should use HTTPS. If you use HTTPS, this would not be possible. This would be encrypted, and you will not be able to access this information. And second lesson, you should never send your password in plain text. Here we are sending just password. You should take an MD5 or a SAL function, encrypt your password, and send it protected. Because even if you're using an SSL, there are methods to attack the SSL. You could make an RPS spoofing, then on a way that your phone that is connected to a Wi-Fi thinks that my computer is the Google server, and it will be sending me everything if you accept the certificate. So the first 2 lessons you can get from here. Here we can see also the response we have sent. And now, when Snapchat have started, I have created 2 different functionalities here. We can take pictures, encrypted or unencrypted. For the unencrypted option, I'm just saving them on the internal storage, no special protection, just saving the file. To encrypt them, I'm using this framework here, Facebook Console. There are many other frameworks. You don't need to use this one. I've been using this one for a while, and I like it. And it pretty much can encrypt any file you want. So now, as an example, I will take a normal picture and encrypt it. Let's hope it's working. Well, maybe not. That's the god of demos. Okay, we'll try again. Sometimes you need to restart those the simulators. But the problem is in a live demo can take quite a while until it's done. Maybe if I change here. This thing over. Okay, let me start the entire application again. Maybe now it's better. Okay, I think my problem is that there is no internet at all. Okay, I probably can correct it very fast. Let me give it a try. I'm gonna deactivate the proxy. Well, you need, when you're gonna use Charles, you need to establish a proxy on the device. That's why and if your IP changes, the proxy might not be working all the time. No, I think no. Oh, okay. Yeah, now since that will work. So if I log in, yeah, I can take a picture. Let's see if now works. No. Well, I will restart and go to the next one. Anyway, I probably can show you some pieces of code here. So the idea when I'm gonna take a picture, I have these 2 functions here. We can request an image that is gonna be encrypted and another one that is not going to be encrypted. So this one will not be up. This one will not be encrypted. If I can zoom in. Or can you see it from there? More or less, can you read the code? Okay. Well, this part from here saves the file normally. If we can here to this function, we just have a normal file output stream. In the save photo encrypted, I make use of this crypto program from Facebook. As you see, it's just 1 extra line, and you're sure that the application is gonna be actually encrypted. Maybe now I'm a little bit more lucky. Oh. Now seems... Okay, and now the camera seems to be working. Huh? Yeah. Now I can take the picture and nobody will be able to see it. Nah, nothing's fine. You will be able to see the demo still good. Okay, so I can take this picture, right? I'm going to take now a picture that is encrypted. So in fact, the one that is encrypted is going to be with my face. And the other one is just this thing moving over there. So this is the other one. Don't laugh at the picture. Now you see I took this one. This is the public one, and this is the private one. If I came now to my file manager, I save them on here on this folder called the snaphack. You see that I have this picture called photo and the one photo encrypted. If I click here, we see that this has been successfully saved. But this one, photo encrypted, cannot be opened. It can only be opened if you decrypt it with the key you have been using. So another lesson for today. For any information that is going to be relevant, encrypt it when you're going to save it to the device. Just don't save it in plain text. Because the effort, as you see, is one line of code. It's not that you have to suddenly change your entire paradigm of program. The keys, that's another topic that I will come later, because the key needs to be secure, more or less. There are a few techniques that you can use to store it securely. Next demo I want to make I'm going to unencrypt I'm going to decompile some APK and then recompile and make some code injection. I have here a hello world APK. So if I install it here, it tells me that there is another application installed. Fine, I will remove and install this new one. If we can hear, this is just a very standard application. Hello world with a hello world Android, so nothing very complex. I'm going to decompile, change some things. In order to do that, I have here one program called APK Tool. Does anybody knows APK Tool? Yeah. So APK Tool basically takes an APK, takes all the content that is inside in smiley files that's similar to the assembler code, and you can start playing with it. We will see that it's very interesting when you can see here. So this is the APK as you download it from the Play Store. If I execute this command, it tells me that the definition, the folder already exists, so I'm going to remove them. Try again. And now I will create a folder called Hello World. And if we can here, we see some interesting stuff, right? We have the Android manifest. That's like the file that specifies the components that you're going to be using in Android. It's already interesting because in this file you put a lot of private keys to connect to Google services and etc. Then we have all the resources, so now we can access to all the images and all the graphic resources. And we have a folder called Smally. Smally, it came from Smally, which is the name of a town in Iceland, and is the language used, the assembler language used when Android is being actually compiled to be read by the machine. Here we see that we have a few files, right? They can be interesting. We have this Hello World activity. If we open that, I don't know if you have been working with any assembled language, but if you have been working with Android, definitely we can start to see things we understand. So we seem to have the name of the class here, the superclass, the source where it has been stored, a constructor, right, a method on create, and we can start. This is a very small example, but for example, we could, I already changed it here. But for example, we could here hello world, Lviv, instead of Android or whatever thing we have. We can start making some changes. I'm going to save, I think it's the same file from here. So what I'm going to do is make a small modification and trying to recompile the file. Yeah. And well, I already made this here apparently. Well, you cannot only change things, but you can make code injection. What is a code injection? When you take code that has been already existing, used for another purposes, and you put in into this APK. For this example, something just very easy, a toast that when you start the application appears and shows the text hacked. How do we do this, you would think? Easy. You have to compile an application that has this code, decompile it, get the smiley code, and then inject it into the application. This is a very simple case. It can get complex. For example, think of the guy I told you that he created an entire keylogger and inject it into the Swift keyboard. That's more complex because you need to be taking care of all those things from here are the direction of addresses, etc. But the important thing here is that this is very possible, very likely, and there is people actually out there doing this thing. Now we will use the same program, APK tool, to build the application again with a different syntax. So what we call this, instead of the D to decompile, we use the V, and we specify the folder. So if we do this, we see that now in Hello World, if we came, there is a new folder called dist with an APK. I will install this APK now in the emulator. Something will happen. Some of the Android developers can imagine that. And first, we need to sign the APK. So that's a good security measure in Android. We are using a certificate. If the certificate is different, or we are using a non-production certificate, it will not be possible to do it. I have created here just a very basic certificate by myself to sign the application. I think the passphrase is 1, 2, 3, 4, 5, 6, like most of the passwords in the world. And yeah, now we have seen the APK. So if I came back to the emulator and I try to install this file, another application, do you want to proceed? Yeah. But now let's see. Do you see here did you see the toast? I can start it again. So we see here the toast hacked and hello world Lviv. So that has been a very fast example done in 10 minutes, but imagine a group of people with resources, what they can do. They can pretty much modify any application in the background and change absolutely the way you work with the application. The next demo I want to make is also a very short demo. It's I want to show you, we were talking before that well, we cannot use the compilation to actually modify safe protection mechanism. So because that's illegal, what I'm using here is a crackme. If you don't know what is a crackme, it's a program that has been already developed to be cracked. So there is people that in their free time create those programs and try to make more effective protections, etc. This seems like a typical case, right? So we have like a name and a serial. We have this in Photoshop and in many other companies. And now I'm going to show you another tool. Instead of using APK tool, I will do it with a file called dex2jar. If you don't know dex2jar, it basically takes the APKs and converts them into jar files, Java jar files. Those files are very easy to manipulate and very easy to read absolutely everything. So I'm going to do this, I'm going to apply the dex2jar to the crackme APK. You see that it says something like it converted into this crackme jar file. And now, if we use Mac, I think it's also available for Windows, we have this Java GDG, which essentially it's a Java decompiler. So you can send any jar file, not an APK, but a jar file. That's why we made this conversion before. And if we open it, we see that there are like some classes, class files that are being read, right? So this was in Spanish, but here we see that there is a Hello Android class, and it seems to be like an activity, right? So the code is not perfect, and it would not compile, but we can start seeing some things. We see that here we are taking like from an edit text and values. Here we are taking from another edit text and other values. We see something like minimum 4 characters. What that means? Probably that if we type only 3 characters, it's not going to work. Exactly, we paint this content. And well, this actually in the real world would take more time because you need to take this code, try to fix it a little bit, try to go through, debug. I already made that for you, so we don't need to spend the entire day here trying to do it. And it's basically this work here compiling. I also write already the output that is going to work. But basically, we can see that here, what we take with all those, we start taking some pieces, right? Like we take the first string, and then we take the telephony manager, which is your phone number, and then we take some substrings, so maybe the first 4 elements, we combine them with another element. And at some point, we check that if all those elements are being equal to the ones we're expecting, then tell to the guy, good boy. So if we came again to our crackme, for example, I calculate this number for this thing here. So if we type 14237 890141, and then a few 6 zeros. Then we see that the message is, if you can see it here, good boy. So you already cracked the crack name. We would see that if we change and put whatever random numbers here, you're a bad boy. As you can see, this is very easy to do, and it doesn't take a lot of complexity. And believe me, not many of the companies are actually taking care of this kind of security. You would be surprised if you download a few applications on how the actual code looks in the real world. I actually have one other application that for me it was a case with them. I was working before for another company, and this company was renting cars, and we saw that some other companies were using our web services, but it was hard for us to prove, are they really using our web services? Because we had like tokens, etc. So by downloading the other APK and checking through the entire code, we actually saw that they were making calls through our API. When you're decompiling those applications, one of the best things to do at the beginning is to check for things like HTTP constants, because obviously when you're going to call to a web server, everything starts for HTTP. So if I click this here, it gets, oh, I think I opened the wrong one, not the APK tool. I want to open this one here, card2jump. And if here I look for HTTP in all the string constants, then we see that things start getting interesting. We can, here in this file over here, we can start seeing that there is something called, a class called backend or something like that. Yeah, backend API. So if I open this one, look how absolutely exposed this is to the real world. It doesn't take any effort. We already have all their backend addresses. I think somewhere else we can also access to the token they're actually using for, maybe it was here, or to the tokens they're actually using to communicate with their backends, etc. And this takes absolutely no effort. It's not nothing that is taking a lot of time to do it. When we talked before about encryption, about obfuscation, sorry. Oh. No, probably it's going to get better. Yeah. Before we talk about using some kind of obfuscation, I'm going to show you how obfuscation looks like. This class here, Crashlytics Android, everything is obfuscated, or most of the things. Do you guys know Crashlytics? It's an external library that you implement in an Android, whatever application, and starts tracking all the crashes you have. In order to, they send it to one server, and you can check them like, okay, I have these crashes in those devices, etc. So Crashlytics, they made it very well, and they obfuscate most of their classes. If I click in here, it doesn't seem to make any sense, right? I open a class called B, and there is like an array and a constructor, but then I have classes called N that they link between themselves. ProWare also makes something very, very smart things like interconnecting classes, even if that leads nowhere, because it will never get called, but that confuses a lot of people. And if you compare, for example, trying to understand this class, or this class from here, how did I make this? Okay, that was a new shortcut. I didn't know it existed. I'll have to check later how to go back to now. So if you try to understand this class, which is pretty much readable, we can see everything that is happening here. Compared with this type of classes, there is no way we will ever be able to do that. So the other lesson of the day: if you're developing an Android application, please forward and obfuscate all your applications. Yeah, well, that's it. I think that's the last demo I wanted to make. As a final point, I wanted to show one of the points regarding how to store keys. Security is never absolute. You have to combine a lot of things together, and even if you combine a lot of things, there will be things like the NSA or any agency that will have resources, time, and people to be able to crack your application. But you can make them have a hard time. If they need 5 years to decrypt whatever important information you have, they're not going to even try. So regarding how to store keys, when we are going to encrypt files, we sometimes, for example, have this method. So here we need a key. We have a method to encrypt and to decrypt, but they need a key. Where can we store this key? Well, in Android, we can make use of the native code. That basically would be, okay, we will have this encryption key where you read this thing. This is just a string, but as we have seen, when we use ProWard, the string is like super readable. We need to put it somewhere else. So if we use native code, that pretty much means native code. We will program in everything on a C++ file, and we will call it from the Android side. So this is how we do it. We will need to create our native interface using this. We will put all our code in name, call it using this function, and our function, this is C++, will be stored in a C file, and return when we call this function getSecretKey, we will return the string we want to actually store. And this will not be readable when we are decompiling the application. So that's, I think that's pretty much everything. There are, however, 3 different things I thought if would be nice to demo or not, but yeah, it's hard when time is so limited, but I think are also important to explain. General things we can apply when we're developing with Android. Please minimize the usage of permissions. If you develop for Android, you are going to install an application and you get this message. Do you want me to read your files? Do you want me to read your calendar? Do you want me to read your location? Unless you need it strictly, please don't use it. I have the luck of living in Germany, which is a very strict country in this sense. And every time I have released an application to the German public, I get like hundreds of messages of, why do you want to read my calendar? Why do you want to read my location? Yeah, because everybody does it. But for me, it was always a good example of how the less I use, the better it will get, because I will not get customer problems or future security problems. Another point, perform input validation. As we made it with the SQL, we should perform an input validation on all the data we're actually reading. So that means there are a few attacks like buffer overflow, which consist on sending a lot of data and until the buffer explodes, and then we can still keep on writing information in different parts of the memory. If we keep some simple control on how the data is being stored and how the data is being validated, we will get rid of this problem as well. And last but not least, I don't know if it will load. Well, my last point was do not load code dynamically. That's a technique that many people use. We don't load code from the backend on real time. We don't load another text and trying to merge it. That's a terrible idea. That's something that is very subject to code injection. So you should never load the code dynamically into your application. Well, thanks everybody for being here. I actually like a lot to get feedback, because I know there are things that could have been done better or worse. So if you send me to this address your feedback. No, not. Yeah. To the address that will appear here, bit.ly feedback LVID. I will send one book I wrote recently to one of the person that writes it there. I will post it later on my Twitter anyway. The book I think is great. It helped me a lot to hire candidates when I was working for a company, and also to find jobs when I quit my company. And well, that's been everything. Thanks a lot for being there. And if you have any questions, I would be more than glad to answer them. This one? Yeah.
Thank you, Enrique. Any questions? I believe our volunteer will help with microphone.
1, 2. I see you use native code to try to protect some security data, but there is also some the compilers that can use also native libraries, and it's pretty easily to get code from there too. So maybe there is some features, easy features, to protect native code from the compiling or something like that for Android.
This is, you're totally right. Actually, it's called security biosecurity, which is proved not to be very effective. But at the end, it's a combination of all of them. For example, in my case, when I want to protect a token, because I don't want it to be public, I hide it with public, doing this way. Even if I know the file is there, I just can go to the object, call the function, and then I return the object. But I do this in combination with ProWard. ProWard generates thousands of functions, and if I see that a function is called getSecretKey, oh, come on, just give me this from the native code. But if I have thousands of different functions, and one of them is 1, 2, 3, 4, 5, and the other one is ABCDE, ABCDF. I'm not going to try all of them because I don't have resources to do that. So it's not effectively. A person that knows where to go will find it. In combination with other things, it slows down a lot a total attacker. But yeah, and also instead, one of the things, ProWare doesn't encrypt strings, so the strings are still feasible. There is a solution called Xward that is paid, is not free, and it's built at the top of ProWare, and they're able to encrypt or obfuscate the string files. I don't know exactly which method they use, but it works totally. You can also set it up, and it's very artistic because you have the artistic functionality of Xware, and when they're actually obfuscating code, they can make like figures, like a Rembrandt or a Picasso or something like that in your code, and then you decompile the code and see, and you have a Picasso, and it's beautiful because you don't want to check it anymore. You just see the code as it is.
We got 3 questions.
Am I right in saying that am I right in saying that if I download an application from Play Store, someone can like decompile it and change it, or it is protected with some certificate?
When you download an application from the Play Store, it's as I have shown you now. The one I saw, this car jump application, I actually downloaded from the.
It is not protected with any certificates?
Yeah, you have a certificate, but you can still decompile it. What you cannot do, obviously, is to sign it with the same certificate.
Okay.
You don't have...
So the new program that is compiled, right, will not be able to access the same store that the original program has.
It will be hard because you would need to steal the credentials for the store, to steal the certificate, to steal the credentials for the certificate. But what happens pretty much every day is that it gets updated into another market, and people that try to download free games.
Okay, thank you.
You're welcome.
There was 2 more questions. Could you please raise your hand? Okay. Here.
So the question is it possible to restrict running your Android application to private storage rather than on SD card?
Well, that's something that the developer chooses. When the developer is writing the function, you have to actually specify in which place do you want to store it. For some of them, they claim, well, it could make sense for some things. If you want to cache, for example, the SD card has much more space than the internal storage. That's one limitation. So if you say, I want to store all my resources for my video game because there are 20 megabytes or 50 megabytes in the SD card, go for that. But in the internal one, yeah, it can also be accessed. So is this, or that's the question you had?
I mean, not storing information from the application. I mean, storing application itself. So there is possibility to move your application from the device memory to SD card. And is it possible to set some restriction and limit those functionality?
When the application is on the SD card, to make the private space private.
When the application is on SD, so not to allow to run application on the SD card. So you just may move your application from phone storage to your SD card storage, right?
Yeah, at the moment it's in the SD card. The SD card is by default accessible from any process. So if you move the application, you can do this thing like manually move the APK. You're solved. Every process can go to your application and check all the information you're storing there.
And at the present moment, there is no protection against
No protection at all. Unless, well, you use these kind of combinations of encrypting your files, which people should always do, but there is no real protection or no protection from the Android operative system side.
Okay, thank you.
You're welcome.
Okay, one last question, please. Here from your colleague.
Thank you for your presentation, for your amazing speech. And I want to ask you about security preferences. Do you know what is it? Security shared preferences?
The shared preferences in Android.
Yep, it's a library which was made by some Android developer. I don't know, and it allows to us keep the token, for example, as secure as possible on the device without use uh, any native methods like was mentioned in your example or something like this. Have you had experience with this or no?
I haven't used it at all, but what you say sounds very interesting because it's pretty much those techniques. But if there is a library that is providing that, that could sound really interesting because serve preferences is something that people use continuously, right? And yeah, I haven't heard of that, but definitely we'll take a look on. It's called serve. You said serve
Security shared preferences.
security serve preferences.
I can share with you
Security.
Twitter.
I think that's a great discussion for offline.
Yeah, let's gonna talk later also.
Yeah.
On,
So Enrique will be here, and probably he will be on the after party today. So in case you have any questions, just don't be shy. Come to Enrique and discuss this question with him. And thanks a lot. Please give a warm applause.
Thanks a lot, guys.